The broadcast is now starting. All attendees are in listen-only mode.
Hi, good afternoon. My name's Andy Overton and I head up the expert support team at C2B2. Alongside me is my colleague Mike Croft, who's also a member of the expert support team. Welcome to today's Java middleware surgery. We've had a number of questions come through, but what we've found is that many of them have been very specific regarding particular applications or very specific problems related to issues one person's having, whereas what we wanted to do was give a more generic overview of some of the problems that we find. So what we've done is we've decided to look at a couple of scenarios which will hopefully be more relevant to everybody, and we'll cover a number of issues that people have raised. So we're going to look at two scenarios or problems today. The first one is related to issues with server slowdown and out-of-memory errors. And the second one is related to issues with consuming JMS messages from a remote queue and those messages disappearing, or issues with those messages getting through. Okay, so I'm going to go through the first scenario. This is the situation where a customer has to keep restarting their servers regularly. They see them slow down gradually over the course of the day, becoming more and more unresponsive, and then in the log files they're seeing out-of-memory exceptions. They find that restarting the server fixes the problem, but this is occurring continuously, and they're having to do continuous restarts in order to get things working again. Now, this is a fairly common area or issue that we see, and I'm going to walk you through now some of the things that we look at when we come across this kind of issue. Okay, so first of all, there's two types of out-of-memory error. One is where it's catastrophic and you've got a rapid rise in memory usage generally over the course of a day or a few hours possibly. The out-of-memory error occurs and the server crashes. There's also long-running memory errors where you get gradual slowdown over time, possibly over days or weeks, again eventually causing an out-of-memory error, but these can be more difficult to detect as they don't happen immediately. Okay, so what should you do if you find you're having this kind of problem? Well, first of all, you need to look at gathering information. When problems do occur, particularly in production systems, the time taken to resolve those issues is always key, and whether that means time taken to restore the affected system or time taken to do root cause analysis to determine the cause and put preventative measures in place. You need to ensure you gather as much information as possible to help diagnose the issues. You then need to look at analysing that information, and we'll cover a number of tools that we use for doing so. And then hopefully from that analysis you should gain a better understanding of what's causing the issue and come up with a diagnosis, and then that should enable you to come up with a solution in order to resolve the issue. Now, in an ideal world, we'd have all the information needed when the error occurs that we can diagnose the issue and fix it without having to wait for it to happen again. But what we generally find is that in most production systems, the information needed when this kind of issue occurs is not there. So the kind of info we're looking for when we get this kind of issue is we're looking for verbose GC. So this is looking at garbage collection and when that occurs and why it occurs. We're looking for heap dumps, which allows us to see what's being stored in memory. We're looking at server logs, so we can view any errors that may have occurred and that may have contributed to the issue. We're looking for stack trace information, so we can look for any long-running threads or stuck threads or other threading issues. We're also looking for details of system changes. Generally when a problem occurs, it's shortly after changes were made to the system, and it may be a simple case of rolling back to a previous version in order to resolve the issue. So how do we go about getting this data? First of all, we'll look at gathering verbose GC data. The GC output's a very lightweight process, and it will make negligible difference to performance. Most of the work to produce the output is done by the garbage collector anyway, so setting verbose GC just saves this to a log file so it can be used. So there's a number of JVM parameters that you need to add in order to gather verbose GC data. The first one is very simple, just verbose GC. It's also useful if you give it a path to a log file. This allows you to know where the logs are going to and to be able to analyze them at a later date. Print GC details. This will cause additional information about the collections to be printed. And also print GC timestamps. That'll add a timestamp at the start of each collection. This is very useful to find out how frequently garbage collections occur. Gathering heap dump data. You need to ensure that when an out of memory error occurs, you take a heap dump. This is not a default setting. This is something you have to set yourself. Basically what it'll do is it'll take a snapshot of everything loaded into memory at the time of the crash. And it's easy to do by simply adding a couple of JVM parameters, as you can see here. One of them is heap dump on out of memory error, and that basically means when an out of memory error occurs, it'll automatically do a heap dump for you. And you can also tell it, similar to the GC login, you can tell it the heap dump path and tell it where to put the heap dump file. You can also gather heap dump data manually. The easiest way to do this, basically you can get the process ID of the running server using the JPS command. This is a command that comes with the JVM in the bin directory alongside java.exe. And that will give you something similar to what you see here. Now the only bit you're interested in at the moment is the first number. It's the first number, and that's the process ID. Apologies. Okay, once you have that process ID, you can use another tool that comes with the JVM called JMap. And this takes the form of basically you call JMap, tell it to do a dump, tell it the format you want, and then tell it which the file you want and the process ID of the running server. Okay, we also want to look at gathering stack trace data. Again, you can retrieve the process ID using JPS as we previously did, and then the basic command for getting a stack trace, we use Jstack. We use Jstack, which is another tool which comes with a JVM alongside JMap and JPS. Basically, you tell it the process ID again and tell it the name of the file that you want to output the stack trace to. It's usually best to take a series of snapshots as opposed to just one. We find one per second for at least a minute when the slowdown occurs. Gives you a good overview of what's going on under the covers. Okay, so once you've gathered all your data, you then need to look at analysing it. So first we'll look at analysing the GC logs. The GC logs will basically show you details of all the garbage collection since the server started, and it'll list all the minor and major garbage collections. So the files are human readable, and there's an example here. This basically says that we've done 2 minor collections followed by a major collection. The next number is the committed size of the heap. Oh, apologies again. And that's this number. And then the last item indicates the time taken to perform the collection. So in this case, we don't really have any problems. We're talking 1.8 seconds for full garbage collection. That's perfectly fine. So whilst you can read them, we'd advise using a graphical tool. We use one called GC Viewer, and this makes it much easier to view what's happening over time, as opposed to having to trawl through the large GC log files. Okay, so when we look at GC Viewer, this is a sort of standard behavior with garbage collection. So we see this sawtooth pattern where you've got the heap growing and then gradually garbage collection, well, eventually garbage collection takes place and the heap shrinks, the heap then grows again, garbage collection takes place, and we see this sawtooth pattern of regular garbage collection, emptying the heap and then it growing again. Some of the important things to look at in the GC Viewer analysis, this data down the side, you've got your accumulated pause time. So these are the times when the application appears unresponsive because the garbage collection is occurring. You've got the average pause time. We've got the total time the application has been running. And then at the bottom we've got a very important one, which is the throughput. And that's the percentage of total time not spent in garbage collection. So you're looking for high figures here. Generally anything sort of 95 plus is not generally an issue. Anything lower than that, you may have issues. Two other things to note here. The red and the blue lines on the graph. The red line indicates the total heap size, and then the blue line shows how much of the heap is actually used at a given time. Okay, so that's looking at standard behavior. Now here we see there's clearly something amiss. We're seeing repeated full GCs, and yet the heap size is still continuing to grow. So this is a sure sign of some form of memory leak and a precursor to heap exhaustion, which would generally be followed by a system crash. So this is the kind of graph you really don't want to see. Okay, so looking at analysing the data we get when we take heap dumps. So a heap dump contains details of all the objects on the heap at a given point in time. The files produced are not human readable. The best tool we find for analysing heap dumps is the Eclipse Memory Analyzer tool. This can help in finding memory leaks and discovering which objects are taking up the most memory. Okay, so the landing page provides access to multiple types of heap analysis. So the two main ones we're going to look at here is the histogram and the dominator tree. So the histogram view will list the number of instances per class, the shallow size and the retained size. So that's the shallow and that's the retained. Generally speaking, the shallow heap of an object is its size in the heap, and the retained size of the same object is the amount of heap memory that will be freed when the object is garbage collected. So the dominator view will list all classes with their fields and references, and the dominator tree displays the biggest objects in the heap dump. You can expand these items to see which objects are referenced by them. And this is a very powerful tool for investigating which objects keep which other objects alive. And that way you can nail down what's hogging the memory, and also the classes or objects that hold a reference to that particular class, preventing it from being garbage collected. So next up, we've got analysing the stack trace. And whilst the files produced are human readable, thread dump and stack trace analysis can be very complex. So to make things simpler, we'd advise using a tool such as WebLogic. This can save a lot of time searching through multiple files, trying to visualize what's going on, and allow you to quickly understand the health levels and get details about threads that are running. So the summary view provides a summary of all the threads, and we can see the grouping of the threads based on functionality or thread group. Now if we look at the advisory map of all the threads, the keyword provides the categorization of the thread, and then we can also see a description. And what's particularly useful is we can get advice for each thread. And if we go into the details view, we can see the status of a particular thread, a detailed description here, and also advice on a particular thread and what's happening at a given moment in time. So one of the really important things to look at when analysing issues is what system changes have taken place. We often find that when we ask people, they'll state that nothing's changed, but generally when issues like this occur, a change has taken place. And the majority of problems that we see are caused by changes being made. So look at things like, have you deployed any new applications recently? Has there been any increased load to the system? Have you made any updates? Or are there any new fixes or patches that you haven't applied that could be affecting memory or performance? Okay, and finally, prevention. So ideally, you don't want this to happen again, or you don't want it to happen in the first place, but you certainly don't want it to happen again. So what can you do to prevent this kind of thing? Well, you should always keep an audit of all system changes and be prepared to roll back if necessary. Now, this should be all changes, no matter how minor they may seem, because one tiny little change can make a big difference. And if it's not audited and nobody knows it's occurred, and it causes a problem, it can be very difficult to find at a later date. You need to make sure that logging is in place, so that when errors like this do occur, you've got the data available, you don't have to wait for another system crash. So GC login, heap dump on out of memory error, and a stack trace if something does occur. And also look at using monitoring tools. These are invaluable for keeping track of normal behavior and being able to detect issues early on. And they also allow you to set up alerts to warn you of things such as heavy CPU usage, or in our case it would be memory usage. Okay, so that's it for the first scenario. I'll hand over to my colleague now, who's going to go through the JMS issues.
Thanks, Andy. So the presentation that I've got is a little bit more of a high-level perspective. It's not going to be quite as technically in-depth. Now, what we would like is for you to give as much feedback as you can on which of these that you prefer, which you feel you got the most benefit out of. Obviously, this is the first time we've done one of these, so any feedback on whether you'd like it to be more technical or less technical would be great. So we'd really appreciate that. So what I'm going to cover really is certain considerations that you might need in various different sorts of problems that you might be seeing with JMS in your production systems. So I've listed a couple of things here that you might see. The first one, just consuming messages from a remote queue. Now I did mean by remote queue external to your organization, but obviously with very large organizations the same problems and considerations need to be taken into account when you are communicating over long distances. Obviously network gaps do make a big difference with this sort of communication. So you might see messages getting lost depending on what your scenario is. These might be messages that you rely on to some degree. You might get customers irate, ringing you up, asking where their messages have gone, transactions aren't happening, or you might not hear anything from customers, and you might just see that you're getting a few network exceptions in logs from your JMS servers. Just by way of an example, if this was WebLogic server, you might see things like no router available to host. Other application servers might report things in a slightly different way, but connection pools can be can have various different sorts of problems related to network connectivity. So the causes of these sorts of problems and scenarios. Firstly, I'll put, do you care if messages get lost? This could be different depending on your particular use of the web service that we're considering. If this is a web service that's used for different reasons by different members of your organization, it could be that the person that's actually written and constructed the application doesn't care if messages are lost. It's not part of their SLA. They've made no commitment or no guarantees about reliable messaging. If it is something that you are concerned about, then that is something that needs to be resolved. If there is disparity between the person that's developed this system and your intended and necessary use of it, then that's a very quick way of getting to the bottom of these sorts of things. Secondly, you need to think about whether the remote JMS producer can be trusted. If you are connecting to an external JMS queue directly, you need to know if that external service has got any service level agreements with your organization. Have they given you any sort of guarantee about uptime of this service? Network connectivity, have they said that you're going to get a direct connection, or if you're just going to be transferring messages over the internet like any other consumer would, or any other end user? You might want to check to see if they've got any connection pooling requirements, or have imposed any restrictions on you in that regard. And then you also need to think about network hops. As I said before, depending on where your the remote queue is, has a very big impact on the reliability of your messaging infrastructure. The more physical network hops it's got to go through, that increases the points of failure that you have in your application, and each one of those is a potential risk, and it just adds and compounds the risk, the total risk of your application. So the solution that I wanted to bring to the table today is message bridges. It's not a new concept. It's a concept that is implemented in any decent JMS provider, but it is one that tends to be overlooked, that we certainly see in our experience. Message bridges are applicable in a vast majority of cases, certainly more than they are used, I would say. And the advantages that they can bring are, well, many and wide-ranging. So I think that the biggest advantage that you can get from using a message bridge, particularly if you have a JMS provider from a large vendor such as Oracle WebLogic, and you've got vendor support, what you're doing by using a messaging bridge to connect to your remote JMS provider is outsourcing the burden of reliable messaging and the complexity that comes with that to your support vendor. If there are any problems that come with that network connectivity, or getting the messages from the remote JMS provider to your message bridge. That's something that you can raise a ticket with your vendor support and get them to look at it. It's one less thing for you to worry about. And frankly, vendors like Oracle with WebLogic, Red Hat with JBoss, they do this thing all the time. It's their speciality, and they're going to be better at it than you are. It's going to be more reliable than things that you can code yourself. I've seen people do tend to try and think that they can code reliable messaging themselves, which is technically possible, but there are such a wide range of fringe conditions that you need to consider, race conditions, network problems that you need to factor in, that it just gets too big to really maintain adequately yourself, and it means that you're not spending time working on the aspects of your application that are important to your users. It's something that it's a lot of effort that can be better spent elsewhere. And lastly, adding a message bridge can bring reliability much easier to a system that's already been designed and deployed than if you're trying to add it yourself as a sort of postscript to your application. There's less refactoring involved, things will be less tightly coupled, and you should be able to reap the benefits much quicker using a pre-configured solution. There are obviously a lot of considerations that you need to take into account when you are implementing a JMS bridge. So I'm going to go through a few of those now. Firstly, you need to look at how complex your scenario is, depending on whether you've just got a very simple point-to-point system, or maybe you've got a wide range of queues and topics, all of them intercommunicating with each other with a lot of mediation that happens in between those. The complexity level and the amount of bridges that you may want to use is going to rise dramatically, and you shouldn't consider a messaging bridge to be a one-size-fits-all pre-built answer to all of your problems and just deploy one and hope for the best. They do make things a lot easier, but they don't get rid of every bit of work that you need to do. So one of the things that you need to consider is whether you use something like WebLogic's JMS unit of work or unit of order. If you've got any single transaction that needs to be spread over multiple JMS messages, what you might find is that if you were to implement this sort of remote JMS connectivity yourself, just one message out of 5 as part of a transaction getting lost means that that entire transaction is lost and needs to get binned. And if that doesn't happen adequately, then you result in inconsistency of data, transactions get started, and you need to monitor not just JMS, but you also need to monitor the transactions that are going on. And obviously adding XA into the mix as well just makes things even more difficult. You'd also need to consider whether you need to load balance JMS across multiple servers. Now obviously the best practice with this sort of thing is that if you've got, for instance, multiple application servers which you've or JMS providers that you've got queues deployed to, you'll need to create a distributed queue or a distributed topic and use the JNDI name of that distributed destination rather than the individual names of those queues. And you can, with most application servers, you can configure whether that gets load balanced in a round robin way or more weighting gets added to each particular server depending on the resources that are available to it. You also need to make sure that you disable any server affinity that your JMS provider has got. Server affinity, for those of you that aren't aware, is where single connections get pinned to a JMS resource, and once they get established, then they always go to that same server. For some scenarios, that is the best route to go down. But if you want full load balancing and you want your JMS provider to decide which server does the work, which is generally the better way to do things, then server affinity does need to be disabled. Another consideration is the JMS provider that you are currently using, or whether you may want to change to a different provider. I've listed a couple here just as an example of the things that need to be considered with JMS providers. If you were to look at the documentation on Apache ActiveMQ, you'll find that it does have a simple JMS to JMS bridge, but it does recommend explicitly that you use Apache Camel, which is a separate product. It does the same sort of message bridging, but it can work with more than just JMS providers. You can bridge between JMS and any other messaging connector that you want that Camel supports, and it does support an awful lot of them. For instance, you can create a connector even to iOS with Camel, or XMPP, or IRC even, for those of the few more exotic connectors that it's got. It is really quite full-featured. The other thing is that Camel is better at decoupling, which is one of the main attractions for a lot of JMS scenarios. You can map multiple queues and topics to multiple queues and topics. So rather than just pinning things point to point, one queue to one queue, or one topic to one topic, you can group those together, use them as sort of pseudo-distributed destinations, and be much more flexible in the architectures that you design. Obviously, it does have a mediation engine as well, so if you wanted to modify any of those messages before you send them on, you can add that in as well. If you're using a provider such as WebLogic that I've mentioned previously, that there might be proprietary standards that come with that application server. So WebLogic comes with SAF, S-A-F, which stands for Store and Forward. Now that's only in more recent editions of WebLogic. So quite a few older versions of WebLogic wouldn't support that. And obviously that is only going to work with 2 WebLogic endpoints. It is recommended by Oracle though. It does work certainly quite differently to a standard JMS bridge, so you do need to bear in mind that setup will be a little bit different with Store and Forward on WebLogic. Now one final thing is that with application servers like, for instance, JBoss, you have JBoss messaging, which is being phased out. Hornet Q is also available to JBoss, and also ActiveMQ is available to JBoss. So you get a wide range of different providers that you can use with just one application server. So that's a classic example of where this sort of thing is quite important. And that's all I had to say about JMS queues and destinations. So thank you for tuning into this surgery. Do please send us in any problems or things that you're looking into in terms of middleware. As Andy said at the top of the webinar, do try and keep them quite generic. We'd like to help as many people as possible as we can with these different problems. Try and make them as relevant as possible. If you'd like a little bit more technical, in-depth discussion, or you'd like things to be a bit more high level, do let us know. Please give us feedback, and we'll see you next time. Thank you very much for listening.
Cheers.